Hey guys, welcome back. So in this video, I am gonna build a stereo home theater system. So this custom made home theater is requested by a client who specifically wanted a bass that shakes his entire home. So I chose general purpose high-end two-way speakers for the left and right channel. Make no mistake, these are not ordinary speakers. These are 6 inches, 8 ohms and 120 watts RMS each. For driving these speakers, I used TDA 7498E based dual channel amplifier board that puts out 100 watts per channel at 8 ohms load. Here is a volume potentiometer and stereo input pins for left and right channel. For powering up this amplifier board, I'm using a 36 volts 10 amps SMPS. I used a speaker grade pure copper wire for satellite speakers. These are two male and female speak-on connectors for both channels. This is an IRS 2092 based Class D mono channel 500 watts amplifier for the subwoofer. These are the audio input pins for the board. This is a 40 volts 20 amps transformer for powering up the subwoofer amplifier. These are 10 amps bridge rectifiers, 15,000 microfarad 63 volt and 4700 microfarad 63 volt capacitors for each power rail and a 10 amps double pole power switch. This is a ready-made ported enclosure for the subwoofer with an L port tuned to 25 Hz. This is a Bluetooth audio receiver for the audio source which comes with a 3.5 mm auxiliary connector. It has a volume potentiometer and auxiliary input and a 5 volts Type-C port. This is a simple low-pass filter board based on NE5532 that comes with a subwoofer volume and frequency potentiometers, a 15 amps power cord with connector, some diodes and 7805 voltage regulators for powering the Bluetooth receiver, a special speaker mesh fabric. Now comes the star of the show, a 12-inch JBL subwoofer rated at 325 watts RMS with 4 ohms impedance. Last but not the least, a speaker protection board for left, right and subwoofer. It requires 12 volts AC to work correctly. Pause the video right here if you're building the home theater yourself and need the connection diagram to follow. Now, while building the power supply, I connected both the 10 amp bridge rectifiers in parallel as I couldn't find a single 20 amp rectifier in local market. I measured the power supply output while connecting 15,000 microfarad 63 volts capacitor at the output, and it read somewhere between 63.5 to 65 volts, which could have gone up to 68 volts during voltage fluctuation. So I changed the 63 volts capacitor and put 3 4700 microfarad 100 volts filter capacitor on each supply rail to be on the safe side. Now I just need to connect the negative terminals of these capacitors and positive terminals of these capacitors, and we are done with power supply. The ready-made enclosure only had space for the subwoofer, so I extended its height by 6 inches with plywood to make space for installing all the electronic components and control mounts. I routed out 2 holes for mounting 2 female speak-on connectors for left and right channel speakers. Then I routed some more holes for mounting the power switch, volume controls and a female power connector, and then painted it all black. I also cut and drilled a small metal sheet and painted it black where all the audio controls will be mounted. Here are the left and right speaker enclosures with their stands and speaker holes, all painted in black. I used a premium looking dark brown fox leather for the finishing work of enclosures. Immediately thereafter, I began with installing the power supplies of both the amplifiers. I then installed the power connector and a double pole switch and then connected them together to the SMPS and transformer. Now, I hacked into the Bluetooth receiver to extend its 50 kilo ohms stereo potentiometer for volume control. I also soldered wires to supply it 5 volts externally via voltage regulator 7805 and also extended the Bluetooth status LED. I also extended the volume potentiometer of the stereo amplifier and installed it in the box. Then, I installed the speak-on connectors and speaker protection board. I soldered and connected them as per the wiring diagram. Now, I installed the subwoofer amplifier board and connected it to the output of power supply and push terminals. After that, I installed the Bluetooth receiver and connected the audio jack. These are 5 volts power input and status LED output wires as I have shown before. These are the extended wires of the Bluetooth receiver's volume control, which will act as the master volume control of the system. This is the extended potentiometer for controlling the volume of left and right channel speakers. These two extended potentiometers are for the low pass filter board, in which the first one is for the controlling of subwoofer volume and the second one is for controlling the frequency. Lastly, the potentiometer plate is fixed, status LED is installed, holes are drilled and subwoofer is soldered. Seems clean and complete, right? But as soon as I began testing, I ran into problems one by one. So what happened is, I just connected those wires here and here at the power input and subwoofer output with my electric screwdriver, and I ended up breaking the terminal blocks from the PCB joint side. And so I was confused why it didn't work at the time of increasing the bass frequencies. So finally I repaired the broken terminals and now it's working as expected. Yeah, it worked as expected, but I ran into another problem. During testing, I suddenly noticed that only left speaker was working. At first, I thought it was a wiring issue, but as I reversed the left and right channel speak-on connectors, I realized that it was an amplifier issue. It took quite some time to convince myself that one channel of the 7498 chip got burnt and it no longer works. It was a really heartbreaking moment for me as it was one of the expensive pieces of the project. And I had no clue why or how did it burn itself. So this is the board. So this 7498 chip just got wrecked, and after doing all this, you can see all the components assembled and this got me. After placing order for another board, I found out that the SMPS power supply that was powering the 7498 board was giving an output of 36.4 volts, whereas the board is said to operate safely below 36 volts only. So I immediately tuned the SMPS voltage down to 32 volts so that the new amplifier board operates safely and reliably. I thought everything was okay, but I ran into more problems, as if previous problems weren't enough. You see, the main transformer's auxiliary output, that is 12012 volts AC, gave an actual output of 10010 volts, which was not sufficient to power on the relays of the speaker protection board. So, I had to install a separate 12012 volts 500 milliamps transformer so that it provides sufficient voltage to sustain the relays. I also had to improvise a 12 volts DC SMPS adapter to provide a dedicated power supply to the low pass filter board because the power drawn from the transformer created audible hums and noises in the main amplifier board, and that is not acceptable. So the build is very nice and the sound quality is very clear. Of course, it's there is no DSP over here, so, and no high cut filter, high pass filter. So yeah, all in all, it's a pretty nice build. Now I just have to cover this one, screw in this to cover this one, and we are done. that's all for today, guys. Like the video, share the video, and do help me by clicking on the subscribe button down here. Also, do let me know if you want a customized home theater for yourself. See you in the next video.